This is the video for lessons 17 and 18. It continues on looking at polynomial inequalities and their applications. Consider the problem. The elevation of a hiking trail is modeled by the function h at x is equal to 2x cubed plus 3x squared minus 17x plus 12, where h is the height measured in meters above the sea level and x is the horizontal position from a ranger station measured in kilometers. If x is negative, the position is to the west of the station, and if x is positive, the position is to the east. Sample problem number 1, selecting a strategy to solve the problem. And here's the problem. At what distances from the ranger station is the trail above sea level? Let's take a look at the solution. So method 1, we're going to use an algebraic strategy and a number line. So we know that the trail is above the sea level when the height is positive. That means that h at x is greater than 0. So we're going to write this mathematical model using the polynomial inequality 2x cubed plus 3x squared minus 17x plus 12 is greater than 0. Step number 2. Factor the corresponding function y equals h at x to locate the x-intercepts. Step number 1 in the step 2, use the factor theorem to determine the first factor. That means we're going to try h at 1. So we'll substitute 1 into the equation and we will get 2 times 1 cubed plus 3 times 1 squared minus 17 at 1 plus 12 is 0. So that means if it's equal to 0, 1 is a factor. So x equal to 1 can become x minus 1 and become a factor. Now, step 2, we will use either long division or synthetic division, your choice, to determine the next factor. So we know the factor is 1, so we set that up on the left side. We take the numeric values from each term, 2, 3, minus 17, and 12. So we take 1 times 2, and then we take 3 minus 2 is 5. So we carry the 2 up to the 2. Then we take the 5 up, and it becomes negative 17 plus 5 gives us negative 12. We carry up, negative 12. 12 plus negative 12 is 0. So that means that x minus 1 is a factor. And the result is 2x squared plus 5x minus 12. So, to factor, we remember that a times b will be 2 times negative 12, which is negative 24, and a plus b is 5. So negative 3 and 8 will give us 2x squared minus 3x plus 8x minus 12. To break it down into groups of 2. So we go one step further. We have x as a common factor, 2x minus 3, 4 is a common factor. 2x minus 3. So we get the factors 2x minus 3, x plus 4. So then we have factors of h at x is x minus 1, 2x minus 3, and x plus 4. Now, we're going to set h at x equal to 0, and we're going to solve. So, we're going to get x minus 1 is 0, x is 1. 2x minus 3 is 0, so x is 3 over 2. And x plus 4 is 0, so x equals negative 4. So, our x-intercepts are negative 4, 1, and 3 over 2. But now that we know that, we need to know which intervals is x above 0 and x below 0. So we take these numbers and we divide them into 4 domains, okay? So 4 intervals. So we divide the domain, into 4 intervals. So our first one, our second one, our third one, and our fourth one. And these are just the values in between our intercept values. Okay, so now what we're going to do is we're going to use these values and we're going to draw a number line. And you can see where I've placed my lines at the x-intercept values. So at negative 4, at 1, and at 3 over 2. And I've divided this now into 4 regions. Region 1, 2, 3, and 4. Okay. Now, from there, you're going to create a table using those intervals. So in green, because there are headings, we write interval, x is less than negative 4. Second interval, negative 4 is less than x is less than 1. Third interval, 1 is less than x, which is less than 3 over 2. And the fourth interval, x is greater than 3 over 2. So now we're going to take a test point from within each region and see if the result is greater than 0. So I want to pick a number that's less than 4, so I picked negative 5. And when I put negative 5 into the equation, I get the result negative 78. I pick a number between negative 4 and 1. Oh, I'm going to use 0. It's the easiest. Okay? I get the value, and it's 12. And it's within my requirement of h at x being greater than 0. 12 is greater than 0. Continuing on, I take a point, 1.2, which gives me negative 0.6. So it's not in my area. And x is less than 3 over 2, which works out to be 6, and it is yes. So identify the intervals where h at x is positive, and we look on our table, wherever it says yes, then we use that interval. So, negative 4 is less than x, which is less than 1, becomes our first interval, because it says yes. And our second interval becomes x is greater than 3 over 2, because it says yes. So those are our intervals where h at x is positive. So what is our conclusion, you ask? Well, the hiking trail is above sea level from 4 kilometers west of the ranger station. Remember, we wanted west